Hello, everybody. Welcome to today's Weather Basics. And we are talking with the fourth graders at Glenwood Elementary School in Virginia Beach, Virginia. They're in the, I guess, the southeast corner of Virginia, right up against North Carolina. And I'm so glad that you guys could join us. We're looking forward to talking to you about the basics of weather and going over just some of the basic ideas and concepts of the weather. And I hope that you get something out of it. I think you guys are in your weather unit right now, so hopefully you can take what your teachers have taught you and take what we're going to kind of lay out for you and just kind of put that all together and just enjoy the weather, because it is one of the things that you can actually do on your own. That's one of the neat things, is that you too can be kind of a student meteorologist, and just by going outside you can take temperatures, you can look at clouds and things like that. So it is a great opportunity. So let me show you, I wanted to show you a weather map here real quick before we jump right in here. Oh, wait. I get ahead of myself so easily. Let me introduce you to the other meteorologist on the call today. Joining me, well, first of all, my name's Tim Bryce. I'm a meteorologist in El Paso. Also in El Paso is my coworker, Jason Laney. How you doing, Jason?
Hi, everybody.
And up in chilly and white Marquette, I want to say Minnesota, Marquette, Michigan, is Keith White. He's a forecaster up there. How are you doing, Keith? Very good. A little bandwidth issues there, but there you go. There you go. So I really appreciate you guys joining us, and I'm going to show you I want to show you my screen here real quick, because this is all the snow that has fallen across the United States up through a couple days ago. You guys there in Virginia Beach, you got some snow over the weekend, I believe it was. That was pretty cool. But guess what? That storm system actually started all the way back in basically the Colorado Rockies. If you can kind of follow it, I'm going to mouse over it here. Here's the Colorado Rockies. They've gotten a lot of snow this season, but this storm dropped straight south, and we're here in basically southern New Mexico. We got snow here in El Paso, almost an inch of snow. And then you can see the storm moved across southern Texas. Places like Brownsville and Corpus Christi got snow. Then it kept going. New Orleans got snow. Places that usually don't get snow got snow. It's pretty amazing. Birmingham, Atlanta got a fair amount of snow, which I understand caused a lot of problems at the airport. And eventually it came across right by you guys there in Virginia Beach. It looked like the heavier snow was just to the north of you, and then gave a fair amount of snow there to parts of New England. So I thought that was kind of cool. Thought you guys would like to see. That's kind of how the weather works. But what we're going to do is we're going to talk about the basics of weather. So I need you guys to pay attention. Let me stop sharing here. I need you guys to pay attention, because we got some quiz questions, maybe some trivia questions. As we're going along, we're going to ask you some questions. So be paying attention. But I'm going to turn things over to Mr. Jason Laney, and he is going to talk about where does the weather all start from? Where does it come from? And here's a little kind of a trivia fact. It's not here on Earth. So I'll let Jason take it from there.
All right, very good. Thank you, Mr. Tim. As he said, that's a question we get asked all the time as meteorologists. What causes the weather? And you'll get all kind of answers, because there are little things that affect weather in different places of the country. But if you really want to go to the top of it and see where it all starts, well, Mr. Tim, if you'll share those slides, we'll be able to tell everybody exactly where the weather all begins. And it all gets started right there up top with the sun. Now, I know you're thinking, yeah, the sun makes sense, because the sun can make it nice and warm on a sunny day, and then when the sun hides at night, it gets a little bit colder. That's right, but it gets a little more complicated than that. So as we move on through our slide presentation here, you'll see exactly what I'm talking about when I say that the sun creates the weather. Now, I said when the sun's out, it gets warm. Well, that's right. A lot of people think that the sun actually causes our air to get hot. You know, when we measure the temperature, we're measuring the temperature of the air. When you go to the doctor takes the temperature of your body to see what your temperature is and whether you're running a fever. Well, believe it or not, the sun does not heat the air. No, it doesn't. At least not directly the way we think about it. You see, the way it all happens is the sun goes straight through all of our atmosphere, through the sky, and through all the oxygen that we're breathing here at the Earth's surface, and it hits the Earth, and the Earth absorbs it. That's called solar radiation, or what we like to refer to as short-wave radiation. But a neat thing that we've learned about radiation, if something can absorb heat, it can give it back. So the Earth starts to give that heat back. And it turns out that the Earth's radiation, the air does a good job of absorbing all of that. So it kind of happens by handing the heat first from the sun to the Earth. Then the Earth turns around and gives it to the air. So that's just a little bit of trivia you may want to remember. The sun heats the Earth, but the Earth is what heats the air. Okay, so now that we got that out of the way, what does all this heating have to do with the weather? Well, it turns out that a fella sailed the ocean blue many years ago. What was it, 1492? I remember a little rhyme that goes like that. Well, there was a belief once upon a time that the Earth was just flat. And then explorers got out and went around the world and found out that it really was round. Well, the Earth is really tiny when compared to the sun. The sun's huge. The Earth's just kind of little. So when the sun sends its energy through this radiation that we talked about to the Earth, it hits the Earth at different angles. Right over the middle of the Earth near the equator, it hits it head on. It hits it strong, and it makes it really hot at the equator. But you start going up in the northern part of the United States or way down south near the South Pole, well, it kind of comes in as an angle. And angled radiation is not as strong as direct radiation. That's what we're talking about here. And that's why near the equator, the sun's radiation is strongest, it gets hottest. And you get up near the poles, the sun's radiation's a little less strong. And if you don't get as much heat energy, well, obviously it's going to get just a little cooler for us out there. So remember that the sun heats the Earth and the Earth heats the air, but the Earth doesn't heat evenly all the way around. And that's kind of important for weather. So our next slide kind of shows you this. Now, in a perfect world, which kind of doesn't really happen all that often, but if you want to talk about the sun hitting right in the middle of the Earth, that's only going to happen a couple of times during the year. That's going to be on the first day of spring and the first day of fall, where the sun is directly over the equator. It can't be over any latitude but one on any given day. Now, we all know that the seasons change, don't they? Well, sometimes it's hotter, like in the summer, and sometimes it's colder, like in the winter. Well, why is that? Well, it's because the Earth doesn't just set straight up and down on an imaginary axis, that axis that goes through the North Pole and the South Pole. It's actually leaning over to one side at about 23.5 degrees, and that's tilted pretty good. So it turns out that part of the year, what we like to call summer, especially the first day of summer, instead of the sun being right over the equator, it's right over this thing called the Tropic of Cancer. And I like to say that weather is all about opposites. Well, if summer is opposite from winter, how does that happen? Well, it turns out that on the first day of winter, or what we call the winter solstice, the sun is no longer over that Tropic of Cancer, north of the equator. The sun is over the Tropic of Capricorn, south of the equator. Wow, this is some weird stuff. So is the Earth literally kind of wobbling one way or the other, one way or the other? Nope. That tilt on the axis is the same. You see what the Earth is doing? The Earth is taking a journey all the way around the sun. It takes it 365 days to do that. And because it's tilted in one direction, over on the left-hand side of your screen, in summertime, where we live, which is called the Northern Hemisphere, we're pointed towards the sun, so we're hottest. And then you go all the way around half a year later, and all of a sudden, the Northern Hemisphere is pointed away from the sun, and we're not getting all the sun's real warmth energy, so that's why it starts to get cooler here. So if I ask you, what causes the seasons, you could probably tell me it's because the Earth is tilted on its axis, and the Earth revolves around the sun. The Earth rotates on an axis. Rotation gives us day and night. A revolution gives us all of our seasons as the Earth revolves around the sun. So that's kind of some cool stuff there that I wanted to share with you. Now, I mentioned the fact that the Earth is not receiving the same amount of energy all the time at the same time. Sometimes the energy is north of the equator, sometimes it's south of the equator. But even areas that get the same amount of energy from the sun don't get hot at the same rate. It turns out that land actually gets hotter than water does. And it gets hotter quicker than water does. It has a lot to do with how land is made up and how water is made up. Water is semi-transparent, and of course, the sun's rays can penetrate deep into it. But if you don't believe me, go to the beach next summer. I know you guys are there at Virginia Beach, and you'll be walking along the beach on a nice sunny day, and if you don't have your sandals or flip-flops on, that sand's gonna burn your feet. I know. I used to live in Virginia. I've been there. But the minute you walk and put your foot in the water feels so cool. That's because land gets hotter and quicker than does water. And actually, because weather's full of opposites, it does the opposite in the wintertime. Land gets a lot colder than the water does. That's why way up there in Michigan, before the lakes freeze over, the ground will be frozen solid and the water will still be liquid. So land and water, they don't heat up the same. So what does all this heating have to do with our weather? Well, when you heat things differently, you end up creating differences in pressure. In general, if the air gets really, really hot, the pressure tends to get low. And when the air gets really, really cold, the pressure tends to get high. So because the sun is heating differently across the earth, because look at this, some places are land, some places are water, some places are north of the equator, others are south of the equator. We get all these different pressures, highs and lows and highs and lows. And that actually comes to play into our wind. Because believe it or not, air always moves from high pressure to low pressure. So think about it. The sun heats the earth heats the air. Some areas get hotter than others. That creates differences in pressure, and differences in pressure create the wind. So in a roundabout way, the sun really is creating all of this weather. And remember, air always moves from high to low pressure, and we call moving air the wind. So we've covered a lot here for you today, high and low pressure. I think there's a little more you need to know about that, but I'm going to let Mr. Keith tell you about that coming up in a couple of minutes. We just wanted to talk about how high and low pressure was created. We wanted to talk about those seasons, and we wanted to talk about how the sun drives it all. So I got a question for you. Remember I said that the Earth was tilted on its axis? That axis through the North Pole and South Pole is not straight up and down. It's leaning one side 23.5 degrees. Now that tilt is very important for something associated with our weather. So my question is it number one, that tilt causes day and night? Does that tilt cause gravity, which is number two? Does it cause winter, spring, summer, and fall, which is number three? Or does it cause the lunar cycle? You know, full moon, quarter moon, new moon. That's a pretty good question. Now, I don't have to hear you. I can just see you guys. You're a good-looking group of kids out there. So what I want you to do, if you think the answer is number one, I want you to hold up one finger. If you think the answer is number two, hold up two fingers. If you think it's number three, hold up three fingers. If you think it's number four, well, you got the idea. Hold up four fingers. So which one is it? What does the Earth's tilt on its axis cause? I see folks holding up not one, not two, but three fingers. What was number three again, Mr. Tim? If you could show us your screen.
Here we go. Number three. The correct answer is number three.
Yeah, they think because it's tilted on its axis, it causes winter, spring, summer, and fall. And you guys are exactly right. I know you've been paying attention. Thank you. But I'm going to give you another question now. And this one might use a little bit of thinking because I didn't say exactly this, but based on what I was talking about, you might figure it out. Remember, the Earth's tilted on its axis. The sun can only hit strong on one part of the Earth at a time. So when it is summer where we live, remember, we live north of the equator, the northern hemisphere. When it's summer in the northern hemisphere, what season is it south of the equator in the southern hemisphere? Is it also summer? Is it the opposite, winter? Or is it one of those other days like fall or spring? Summer's 1, winter's 2, fall is 3, spring is 4. So when it's summer where we live, what is it down in South America? What do you guys think? Let's see. All right. I always rely on the people in the front row because I can see you better, but I see hands going up way in the back of that room, and everybody agrees that it's winter. I said, weather's full of opposites, isn't it? Well, remember, when the Earth is tilted towards the sun for us, down south of the equator, they're tilted away. They're not getting the main strength of the sun like we are. But it looks like we're headed to the time of the year where it's going to be winter here and summer there. But those folks down there, they have high and low pressure. We have high and low pressure.
Yes.
Mr. Keith, what's this all about?
I don't know. Keith, can you still hear us? He's having bandwidth issues.
Oh no! Oh no!
It's okay.
Well, I'll let you pick up if he can. If he
yes,
can,
so I'll go ahead, Keith. If Keith can hear me and can chime in at any time, but I will go ahead and show you my screen here because we're going to talk about high and low pressure. When you guys look at that weather map, and you see, if you ever look at it on TV, you'll see some H's. You'll see some L's on the weather map, and that stands for high pressure and low pressure. And we're going to talk about that. Jason mentioned that. Mr. Jason talked about the highs and the lows, and that's, remember, that wind goes from the high pressure to the low pressure. If you've got like a balloon, that's kind of like high pressure. If you open up the end of it, it lets that air out, and you know that air blows along, and that air is actually going to an area of low pressure, which would be the room, and that air as it moves, that's what we call wind. So if you look at the weather map, you will see areas of high pressure and low pressure, and that really makes a whole lot of our weather. So let me go forward here. Let's talk a little bit more about each of these. You'll see a big H on the map. That stands for high pressure. And that just means it's a big mountain of air, if you can imagine that, in the atmosphere. High pressure, we tell people high pressure usually leads to happy weather. So you can remember that, high pressure, happy weather. It usually means clear skies, calm conditions, dry weather, you know, warm temperatures during the day, maybe some cool temperatures at night. Now, sometimes during the winter, you can have a big area of high pressure and it can be actually very cold, but most of the time we have high pressure. We still get that sunny weather, calm winds, and nice dry conditions. Could be warm, could be cold, but basically high pressure gives us that happy weather. Low pressure, on the other hand, wow, that gives us our lousy weather. It gives us cloudy skies. It gives us windy conditions. It gives us wet weather. And many times it can be followed by colder weather. Basically, if high pressure is a mountain of air, low pressure is a valley of air. And you guys have always seen maybe like water. If you pour water on top of a hill, does the water stay up on top of the hill? No, it runs down the sides. If you pour water in a hole in the ground, does the water jump out of it? No, it stays in there, or the water fills in there. And that's what is happening in the atmosphere. The air, it behaves very much like a liquid. So it's always moving from that mountain of air down into the valley of air. It's always moving in that direction. And basically, if you can imagine that valley of air, the water is coming in, or in our case, the air is coming in from all directions. Have you guys ever seen one of those, maybe a movie or something, where you have two cars that are coming along at each other and they come together and bang, they hit head on? What happens when those cars, they hit? Do they dig down into the ground, or do they bounce up into the air like that? It's what happens when they bounce up into the air. It's the same thing that's happening up in the atmosphere that gives us our clouds and our rain. Is in the low pressure, all that air is rushing towards the center of that area of low pressure, and it's banging into each other, and it's forcing itself up. To get clouds and to get rain and to get all kinds of weather, you need to have upward motion. I don't know, let me go back and show you real quickly one other thing. Back on the other screen here, on the high pressure, you see it has sinking air. The air is running away from the mountain, and there's air replacing it from above. So in high pressure, you have that sinking motion. That's why you have the nice clear skies, calm conditions. And in the low pressure, all that air is rushing towards the low, crashing into itself and going up. And that's what you get, is that lifting air. And that's what gives us a lot of our weather, is that area of low pressure. Now, this is kind of what a typical weather map. This kind of shows the southwest area of the U.S., Oklahoma, New Mexico, Texas, a little bit of Kansas and Colorado, even the Four Corners there. So basically on a weather map, many times you'd see an area of low pressure. On the backs of it, you would see this area of high pressure. Many times the high pressure is kind of where that cooler air is as it's coming in. You got the low pressure extending to the south of it. Many times is this big blue line. That's a cold front, and it has some triangles on it. The triangles tell you which direction the cold front is moving, And basically, it is a place where the cold air is replacing the warm air. And so that's why it's called a cold front. It actually started in World War II, where they had the armies moving around on the map. It's kind of where they came up with it. So a front is where the air is changing places with each other. And in this place, it's the cold front replacing the cold air is replacing the warm air. But you also see a red line coming out kind of to the east of that low pressure center. It's a red line. It has little red circles, half circles on it. The red circles kind of show you which direction that warm front is moving. And basically that warm front is showing you where the warm air is replacing the cooler air to the north of the low. And Mr. Keith, are you back with us? Can you hear me?
Yes. Can you hear me?
You sound great, sir. Do you want to go ahead and take it from here?
Yes, absolutely. Thank you. My apologies for the connectivity issues.
No problem. So we just finished, we just talked about high and low pressure, and now I just kind of laid out the typical kind of low pressure with the cold front and the warm front, and I believe the next screen talks about warm fronts and cold fronts.
Sure. So we'll start with the cold front on the top there. As you can see, the cold air is moving from the left side of your screen to the right side of your screen, and it's a very deep layer of cold air with a steep front. So the warmer air on the on the right side will begin to quickly rush up along the border between the cold and the warm air. And that's where you see the showers and thunderstorms building in that area as air rises and condenses the water vapor within it and makes those clouds and storms. On the lower section, the warm front is much less steep, much more gradual, and typically a little bit more slow moving. And you can see that the warm air sort of moves, slides up and above that cold air. You still get that condensation and forming clouds, but they're more broad, not necessarily as tall, and they don't always rain as heavily. If we can move on to the next slide. So here we have a map of Texas and Oklahoma. You can see New Mexico there. There's a cold front that hasn't quite moved into Texas yet. Temperatures around 85 in El Paso, and then in the mid to upper 70s for much of the rest of the state of Texas. But in 24 hours, that cold front moves to about the center of the state. Behind it, much colder, 52 up in Amarillo or Lubbock, and then still warm out ahead, even just in front of it, 82 degrees right before that cold front moves through. And then in 24 more hours by Wednesday, you'll see the cold air has continued to rush in across the entire state, with just the southern tip of Texas still holding on to the 80s. And looking at the types of weather you'll see, it's typically sunny far away from the front in southeast Texas near the Gulf of Mexico, maybe some partly cloudy skies in the central portions of the region. And then by the front, out ahead of it, you can see thunderstorms and probably some rain showers behind it as well. All of that weather's happening at the interface between the warm and cold air. So in 24 hours, we move to central Texas. Behind the front in El Paso and Amarillo, we have sunny skies again. Most likely there's high pressure in those areas starting to build in. Then central, those storms are out ahead of the front with rain still following behind. And by Wednesday, that area will have moved all the way to the Gulf Coast of Texas.
Very good. So you get very vigorous, very active weather right there on the front. So I think we got a couple questions. Can you read those, Mr. Keith?
Sure. So the first question, the most common type of weather associated with high pressure is either 1, cloudy skies, 2, gusty winds, 3, sunny skies, or 4, thunderstorms. Let's see those hands in the air with some fingers. 1, 2, 3, or 4.
Guys, remember, what kind of weather do we get with high pressure? Is it 1, cloudy skies, 2, gusty winds, 3, sunny skies, or 4, thunderstorms? I'm seeing some 1s, I'm seeing some 2s. Let's see what the correct answer is. I'll show you my screen again. Boom. Sunny skies is it. Remember that high pressure gives us the happy weather. Happy weather. So that's usually sunny skies. It's not clouds. It's not thunderstorms. So good job, guys. Here's another question.
All right. So the most vigorous weather, for example, thunderstorms, will occur with what kind of front? Is that going to be a warm front, a cold front, an occluded front, or none of the above?
Did we even talk about occluded fronts?
We did.
So so it was warm front for 1, 2 is cold front, 3 is occluded front, and 4 is none of the above. So what type of the most vigorous weather is it? 1 for the cold front or warm front, or 2 for the cold front? What do you guys think? You guys remember? I see some 1s, I see some 2s. Let's see, the most vigorous kind of weather shows up. Let me present my screen here. Whoop, I was presenting it apparently. Can you see that there? It's the cold front. It's the cold front. So anybody who is holding up 2 fingers, that's where you get your most interesting weather, the most, I guess you could say, vigorous weather, those thunderstorms. So that's right there. Good job, everybody. So excellent, excellent work. So what is next here? We're going to talk about, we're going to talk about water. Keith, do you want to talk about water, or do you want me to talk about water?
You go right ahead.
Okay. So we're going to talk about water because it is amazing. The water is one of the most amazing molecules on the earth. Let me get my screen up here. It is so cool. I know you're there in Virginia Beach. You've seen water. You've seen the waves. They come water, water. You saw that was some liquid water. You saw some frozen water the other day as the snow was falling. And then all around you in the classroom, believe it or not, your classroom has water vapor, or the gas of water, just floating around in it. Water is totally cool. It's amazing because water is the only substance that exists naturally on the earth that can be in the physical, all 3 physical states of matter. And you guys remember your 3 states of matter: solid, liquid, and gas. And that's so cool because water can exist at the same time on the surface. And we've all seen that. You've seen the snow, you've seen the water in the ocean, and in your classroom is that water vapor. Now, since the air is just filled with all of this water vapor and the water in the different places like the clouds and the ocean, we have what's called the water cycle. And I'm sure you guys may have heard of this. And basically the water cycle is it's the greatest recycling program ever invented, because the water that we have now is basically the same water we've had for the last at least 1,000 years, if not longer. Basically, you have all this water in the oceans and in the rivers and in the lakes, and it's sitting there. And then, like we talked about, the sun comes out and it shines on that water and it heats those little molecules up. And what happens when you put a stove or put a pot on the stove and turn it on? Eventually, if there's water in it, you get that steam. And eventually, if you leave it there long enough, all the water disappears out of that pot. What that's called is evaporation. So in the ocean, it's not quite as vigorous as when it's on a stove, because we don't get to boiling, but you do get evaporation out of the lakes and the oceans and the rivers, and that goes into the air. We can't see it, but it's there. It's in the atmosphere as a gas. Now, as that gas rises, it starts to cool. And one of the cool things, no pun intended, one of the interesting things about a gas is as it cools, the temperature-wise, it can't hold that water vapor anymore. And it starts to go back from a gas into a liquid, and it's what we call condensation, and it starts making clouds. And you guys have all seen condensation. During the summer when it's hot, what do you go run and get? You get a soda can with some soda or some pop in it. And what's on the side of that, if it's cold, you get those little beads of water on the side. That's condensation. As the warm air during the summer touches that can, it starts to cool down, and immediately the water vapor gas in the air, it cools down and it can't stay a gas anymore, so it becomes a liquid. Same thing happens in the atmosphere. It's just there's not a big soda can involved. It starts to cool that water vapor and it condenses that water into a cloud. And if you get enough clouds and they get deep enough, and maybe sometimes they're associated with, like we were talking about, an area of low pressure or a cold front, you can get some rain. Or if it's cold enough, it may be in the mountains, you get snow, or as you guys saw, sometimes you can get snow all the way down to the sea surface, all the way down to the ground. So, but it has to be cold all the way down. So that condensation makes the cloud, and if it gets thick enough, we get the rain and the snow, and that's precipitation. And then that runs off the mountain. If it's rain, it runs off into the lakes and the oceans. If it's snow, it will sit there for the whole winter. And then eventually, as we start to go into spring, it'll start to melt. And then that water will either seep into the ground as groundwater, or it will run off into the lakes and oceans. And then guess what? The sun shines on the lakes and the oceans and the rivers, and it causes evaporation, and the water vapor goes into the air, and we get colder, and we get condensation, and we get precipitation, and it just keeps going in a great cycle. And like I said, it's an amazing recycle program. So it's just so cool how we just keep getting that water going, and it keeps going and going and going. So just remember that we start off in the oceans, we evaporate, we make the clouds, condensation, then we make the rain, precipitation, and then it runs off into the oceans where we start it all over again. Amazing. Now, sometimes when you get enough of those clouds and they all get organized, we get one of the greatest storms on Earth. And I'm going to tell you about it right now, and that's called the hurricane. It is one of the greatest storms on Earth. And I know you there in Virginia Beach, you're not in maybe the bullseye of Hurricane Alley, as you could call it, I guess, or where it's most likely to occur. But you definitely have a threat. Being there on the Atlantic seaboard, you definitely have a threat of seeing the effects of a hurricane. Now, I know this year we had Hurricane Harvey in Houston. You had Hurricane Irma in Florida doing a lot of damage in the Key West area. And then you had Hurricane Maria in basically affected San Juan and Puerto Rico down there. So we had three big hurricanes this year. And we're going to talk about hurricanes just a little bit here. So basically, hurricanes happen all around the world, but they don't call them hurricanes. Only in North America and the Atlantic Ocean and in the central and eastern part of the ocean do we call them hurricanes. In other parts of the world, it's the same kind of storm system, but they're called different things. In the Western Pacific around Japan and China and the Philippines, they're called typhoons. In the Indian Ocean around India, places like Myanmar, Bangladesh, they're called cyclones. And then off the west coast of Australia, they have a funny name for them. They're called Willy Willies. Now, that sounds like a funny name, but guess what? These storms are nothing to be laughed at. They can be sometimes very dangerous and very powerful. Basically, again, what a surprise. A hurricane is a big area of low pressure. Remember we mentioned about a hurricane giving you, or areas of low pressure giving you lousy weather. Well, here's a great example. It gives you really lousy weather. Basically, hurricanes get their fuel, get their energy from the warm surface waters. So you're not going to see a hurricane like up in the Arctic Ocean. It's just too cold up there. You're not going to see, it has to be very warm waters. That's why the Gulf of Mexico, and during the summer, the Atlantic Ocean starts to get warm enough as that sun's been shining on it all summer. But basically, remember, if you don't eat breakfast or lunch, you're going to get tired and weak. And the same thing happens to the hurricane. If it gets cut off from its warm ocean waters, it starts to get weaker and weaker. And that usually happens when that storm moves inland. It gets cut off from that warm moisture. And once it comes over the ground or the earth or the land, it gets cut off and it starts to immediately get weaker and weaker. But like Hurricane Harvey was a great example. It started to come inland, and then the weather currents kind of took it back out into the Gulf. So it actually got an extra, grabbed a quick snack there in the Gulf of Mexico and brought in a lot more rain into Houston and caused a lot of rain in Houston. So just remember, the hurricane takes that warm air, that warm waters, and makes it that moisture that condenses. We talked about the condensation, and it rises, and it gives you this big storm. Now, hurricanes can many times be very, very large. Kind of here's the schematic, or kind of the design of it. The hurricane's got three parts: the eye wall, and the spiral rain bands. Now, when I'm talking about the eye, I'm not talking about the eye like you and I have. The hurricane's not looking around, seeing where to go. It's just what they call the eye, and it's right in the middle of the hurricane. As a matter of fact, I got a demonstration here I want to show you real quick. Imagine a hurricane is like a pinwheel. Boop, 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 boop. And it's got these little, it spins around like this. If you watch a hurricane on a satellite map, you'll see it spinning and spinning and spinning. And but right in the middle is what you could consider the eye. And you can see it's actually not moving in there. Everything's spinning around it. So basically, you think of a hurricane as a big pinwheel. And what happens is that in the eye, you saw how the eye on the pinwheel wasn't spinning around. In the eye of the hurricane is actually light winds, calm conditions. The sun actually comes out. And what happens is that people sometimes get fooled. They'll be in the hurricane, the eye will come over, the sun will come out, and after all the wind, the people will go outside and they go, oh, okay, it's over. And they don't realize that the backside of the hurricane or the back of the eye wall where the strongest winds are is coming. So what happens is that the eye of the hurricane is actually calm winds, but right next to it, surrounding it, is the eye wall. And it's just a bunch of thunderstorms all surrounding that eye, and it has the strongest winds and the heaviest rains. And then spiraling out from that, remember it's kind of like a pinwheel, are what we call the spiral rain bands. And they're just lines of thunderstorms, and you can actually see them on like a satellite loop or a radar loop, that these bands are just pinwheeling in, and they're just a long line of thunderstorms. So basically, in these rain bands, you can get some heavy rain, maybe every once in a while a tornado. So you got the spiral rain bands, you got the eye wall where the strongest winds are and the heaviest rains, and then you got the eye. It actually, like I said, kind of gets calm there. The hurricane has lots of threats. It's got very strong winds. It's got lots and lots of heavy rain. One of my coworkers is from Puerto Rico. He said parts of Puerto Rico were getting, 30 inches of rain. We know that Houston got 40 inches of rain. So they bring a lot of rain, and then they also bring, believe it or not, they bring a big wave in. When the hurricane comes ashore, it raises the level of the sea and brings it in, and we call that the storm surge. So the hurricane is an amazing storm system, and it's actually hundreds and hundreds of hurricanes or the thunderstorms that have all gotten together, and that they kind of join forces. And like I said, they're that big pinwheel, as it is a pinwheeling in and headed towards. Hopefully it just stays out over the ocean, but we've seen, especially this year, how they can start to affect our people. Oh, yeah. I forgot. I got one more slide I wanted to show you here, because a lot of people ask, hey, why does the wind in the middle of the hurricane stay calm? I think you kind of saw that on that pinwheel. Everything was rotating around the eye. Basically, all that air, remember how we talked about all the air rushing towards the area of low pressure? As it gets closer to the area of low pressure, it starts to move faster and getting closer. It doesn't go straight into the area of low pressure. Because the Earth is round and because it's spinning, it actually kind of pushes the air off to one side, and you end up with that kind of counterclockwise. If you look at a clock, it's going opposite the way the minute hand goes. So if you watch a pinwheel, the hurricane is actually spinning opposite of the way the clock works. And so the wind kind of circles that area of low pressure in the middle, so that in the middle, it's actually calm winds, and actually they're sinking down winds right in the middle of the hurricane. But right around the edge where the winds are kind of bumping into each other, you get those winds colliding, and you get that upward motion. That's where you get the thunderstorms, the strongest winds. So that's why the eye wall of the hurricane has the strongest winds, and the actual eye itself has the calm winds. I think we got some questions in here. Nope. We're going straight into weather and climate. And if Keith and Jason, you don't mind, I'll just keep right on going here. So very good. So real quickly, we're almost to the end, and then we'll try to figure out if we can get some questions from you guys. So basically, and hey, I don't know who the teachers are there. If we can't hear your audio, whoever has my email address, if you guys want to email us questions and we'll try to answer them, that might be one solution if we can't get your audio to work. But anyway, all right, I just wanted to throw that out there so you guys can be thinking about that. We got a couple minutes. We're going to talk about weather and climate, because weather and climate, they sound very similar. We talk about them we intermix them all the time, but they are kind of different, and they're different, and we need to understand the difference so that when we're talking about them, we know what we're talking about. Because you'll hear about people talking about weather all the time. You'll hear about people talking about climate and climate change all the time. But basically, weather is weather. It consists of short-term, maybe minutes or days, variations in the atmosphere. When we're talking about weather, we're talking about temperature, humidity, precipitation, cloudiness, visibility, and wind. And we all know this. If you look out the window right now, you're looking at weather. Climate, on the other hand, climate is the average weather in a place over many, many years. While weather can change in just a few hours, climate can take hundreds of years or even thousands of years to change. It takes a very long time to change. You can't look out the window and see climate, but what you can do is look out the window over maybe like 10 years and average up all the weather over that time, and then you'll kind of see the trends. That's what climate is. Let's see, another way to talk about weather and climate is, weather happens in a particular place and a particular time. Where climate happens over a regional area, kind of a larger area, and over a long term. There in Virginia Beach, you can say during the summer, our climate is warm and sunny, and we expect great weather. That's your climate. But if you get down to the actual July 3rd, maybe, and it rains on that day and it's cool, that's weather. Your climate is, most of the time, it's sunny and warm during the summer. But your weather is maybe that one day you get that thunderstorm or you get cloudy skies and it ends up making you colder than normal. And that's your weather. Another way I'd like to describe it is if you watch the news, you're watching the news on TV. News is happening at some location, and it's happening right now. Maybe a bank got robbed, and that happened in the morning, and that's happening right now. Versus history, which happened over an area over a longer time. So if we're talking about like maybe World War II, happened in Europe over many years. So that's the difference. Weather is like news, it's happening right now, and climate is like history. It happened over a longer time period and usually covers a greater area. And the last thing to remember when you're talking about climate and weather, and this is kind of the way to remember it, and I talked about it for Virginia Beach, climate is what you expect, but weather is what you get. So you may expect it during the summer to have sunny, warm weather in Virginia Beach, but you get that one day with clouds and cooler weather and maybe some rain. Weather is what you get. So having said that, that is our presentation. Oh, wait, I think I've got some questions here. Let me double check here. Oh, yes, two more quiz questions, and then we will try to answer your questions if we can figure out the audio. So let me go back up here to my screen, and we're going to show you the question here. All right, put your thinking caps on. Here we go. What is the fuel source for a hurricane? We talked about where it gets its fuel. Is it is it 1, warm ocean water? Is it 2, my favorite, peanut butter and jelly sandwich? Is it 3, the rotation of the earth? Or is it 4, cold ocean water? Let's see those fingers. Who can remember? I see some ones. I see ones. There's ones. I see lots of ones. Let's see what the answer is. I thought it was the peanut butter and jelly sandwich because I'm kind of partial to that. But no, it's the warm ocean water. Awesome. You guys did great. All right, let's go back over here. All right. It's my favorite. It's a true or false question because guess what? You got a 50-50 chance of getting it right if you don't know the answer. But guess what? I know you guys know the answer to this one. All right, I'm going to read it to you. True or false? Climate is the average weather in a region over many years. Is it 1, true, or 2, false? Let me see those fingers. You guys remember? Is it 1 or 2? I'm seeing the 2s. I'm seeing some 1s. Let's see. The answer is, it is number 1. Climate is the average weather in a region over many years. Remember, weather is happening today, right now, as you look out the window. climate happens over a longer period, and it's an average over those time frames. So that is our presentation for today. There's some email addresses. I don't know if you guys have emails yet, but your teachers can email us. So you guys did great. I'm going to stop presenting here. Let us see. So that's our presentation today. You guys did great sitting there patiently listening to our presentation and answering our questions. But I don't know if we can hear our friends over there in Glenwood Elementary. So go ahead and let's see if we can hear you guys. Oh, the teachers are thinking. If you click on the gear at the top of the screen and then choose a different, it'll give you a drop-down window, and one of those will be a microphone, and you can choose maybe a different microphone setting. That might work for you. They're troubleshooting. They're looking intently. The kids are anxious. I'm still not hearing anything.
Hey, Mr. Tim, maybe if we can't get their audio, they can write it on a piece of paper right quick and just hold it up to the camera. That'll work.
That's what I was thinking. They could email us, or they could write it on a piece of paper. We'll be happy. We're flexible here. We'll take questions however we can get them. There's Jason. Oh, Jason's got, that's weather guidance, isn't it? Hey, Jason, while we're writing out questions, can you kind of turn around and tell them what's behind you?
Oh, sure. I tell you, that'd be a great idea. So let me kind of get out of the picture here so that everyone can see what I'm looking at. This is our operations center here in the El Paso National Weather Service office. We have 122 weather service offices all around the United States, and each one is located in an area specific to the people that are around them. For instance, for you guys over there in Virginia Beach, just up the road from you, about halfway from you to Richmond, is an office in Wakefield, Virginia. And inside their office, it looks a little like this as well. But you can see all the computer screens that we work at, the monitors that we watch to keep an eye on the weather around us. So it's a busy place. Most of the people in my office right now, they're kind of camera shy, so they won't get in front of the camera, but they're back there. Okay, we got some audio, don't we, Tim?
At least we got a question. I can see it.
Okay.
Okay. It says, why does the weather change so quickly? Is that the question? Why does the weather? Yes, we're getting yes. So why does the weather change so quickly? And I agree, sometimes it changes slowly. Here in El Paso, we got a week of sunny, warm weather. So we're not seeing quick changes to the weather, but I certainly know it can change very quickly. Actually there, Keith, why don't you talk about what's going to happen there in Virginia Beach, because they're going to have a weather change happen. They're kind of warm today. They're going to be much colder tomorrow. So what's going to be that change for them?
Sure. So from what I've seen, I'm all the way up here in cold and snowy Marquette, Michigan, where it's only 10 degrees with 6 inches of snow on the ground.
Holy mackerel.
I can tell down there, you guys are in about the 50s today. But later tonight, one of those cold fronts we were talking about is going to move through your area. And sometime between now and when you wake up tomorrow morning, it'll be about 25 degrees colder thanks to just that one boundary moving through your area. So it's typically about different kinds of boundaries that will change your weather very quickly, whether that be a cold front or a warm front, or sometimes even smaller scale things related to other weather phenomena.
Very true. So it's a cold front. Sometimes it's those areas of low pressure. But basically, as that weather moves along, if you're in where the main weather pattern is, and that kind of shifts, we call it the storm track, you can see some big changes in your weather from day to day. El Paso right now is way out of the storm track for us. Like I said, we've got a week of nice, sunny, warm weather. But by the end of the week, into the weekend, it's looking like one of the storm tracks is going to kind of dip down to the south, and it looks like we could get some weather. So basically, like Keith was saying, sometimes it's a cold front, sometimes it's the areas of low pressure. But if you're in that right place, as the weather moves from west to east, you can get some definitely big changes in your weather. Great question. Does someone else got a scribble question for us? I like this. This is the first time we've done the questions like this. Oh, now we're getting technical. What will happen if we did not have weather? I can answer that one. That's a great question. the answer to that question is I would not have a job if we did not have weather. Hey, Jason, can you talk about, we talk about hurricanes, we talk about the uneven heating of the earth. What is the weather actually doing behind the scenes?
Okay, well, whenever I talk to students, I always tell them one thing. Weather is nature trying to achieve a balance. If you guys go out on the playground today and you put 3 or 4 children on one side of the seesaw, do you even have seesaws anymore? And you only put one child on the other side of the seesaw, be a very fun day on the playground because one side's going to always stay down and one side's always going to stay up. What's better is when you have students of basically the same size, kind of enjoying the seesaw, going one side to the other. If we didn't have the mechanisms that caused weather to change constantly, what would happen is the equator would keep getting hotter and hotter and hotter, and eventually it would just kind of boil away. And then folks up to the north would get colder and colder and colder until everything just froze over into a great big ice age. But the beauty of weather as we know it, the constant changing or movement of air masses, means when it gets too cold in one place and too hot in another, they kind of move towards each other. And that movement of cold air masses and warm air masses means we start getting weather. So basically, to answer your question, if we didn't have weather, we could not exist on this planet. Yeah. So it's a good thing that weather does what it does. Sometimes we don't like it. It ruins our soccer match or kind of gets in the way of a picnic or playing outside, or it gets a little too cold or too hot. But weather's a good thing, trust me, not just because it's how I make my living.
Very good. All right. What's the next question? Great question there. I love it. They got a whiteboard and a Post-it. Let's see. Oh, I can't see. Can't see.
Move it a little bit closer, maybe.
Oh, there it is. Why do we have high and low pressure? Very good. Why do we have a little high and low pressure? That can get very technical. I'll let Keith kind of, I'll let him answer that. But basically, you see the weather maps. You have those H's and L's, and we start to get those air moving. And one of the good things is, as the air moves along, it's kind of making more H's and L's. But Keith, why don't you talk about that here just for a second?
Sure. So this actually is kind of related to the previous question. As Tim was saying, you have to have weather to move the energy from the hot portions of the equator, the center of the Earth's belt, to the poles where it's typically colder. So the only way to do that is to move the air. And when that air moves, it has to collect in certain spaces. And when it collects in one space near the ground, that's when you have high pressure, and the air needs to move away from that. And where it goes is towards the low pressure. Mm-hmm. And the two sort of, intermix. They work off of each other.
Mm-hmm. And basically, as the air is moving along there, it actually forms other areas of high and low pressure. We like Jason said, we never achieve that balance, that perfect balance. The Earth is always trying to get balanced as far as the weather goes, but it never quite makes it. We never run all the air away from the high pressure. We never fill in all the low pressures. As the air is moving towards those, they create other areas of high and low pressure, which is what keeps our weather going. Great question. Who's got another question there for us? All right. We got lots of creative things. Closer, closer, closer. Oh, wait, I can see it. There we go. How can you predict the weekly weather? Jason, you are in the forecast operations area. Talk about your forecast process.
Well, the forecast process is pretty similar. It's just like any other scientific process. If you go to a science fair and you have to do a science project, you're first going to generally think about the problem that you're going to solve. In my case, what's the weather going to be? You're going to make a hypothesis. You're going to think, okay, it's winter time, so I think the weather's going to be cold. But then you're going to do some experiments and take some observations. Now, you may do different things with different tools. What I'm going to do is I'm going to look at weather instruments that are going to help me observe how hot it is, how cold it is, how heavy or light the air is, whether the air's moving, if it has moisture, all those kind of things about weather. And I'm not just going to look here. I'm going to look over there, and better than that, I'm even going to look up there in the sky. Then I'm going to take all of those observations and I'm going to put them into a scientific model that is going to more or less be a model of what the air is going to do. If the air is doing this here today, maybe it'll do this here or there tomorrow. And then when I put it all together, I have my general idea what I think is going to happen. I have my observations with all of the weather instruments that Mr. Tim has up for us right there. I put them all into the fancy computers and the forecast models, and it gives me a forecast of what I think is going to happen. Now, I have to tell you, forecast models don't always get it right. And
What?
you might not believe this. Yeah, sometimes I don't even always get it right. Most of the time I do, but not always. And so then I have to use my local knowledge, because I may not know exactly what happens in Virginia Beach because I don't live there. You probably know Virginia Beach better than I do. But I live right here in the desert of El Paso, Texas, where we have mountains and cactus and coyotes and rattlesnakes. And I know what the weather does around here. So at the end, I use my own general knowledge of the area, my understanding of how weather happens, and the information that I get from my forecast models to know what the weather's going to happen tomorrow, what the weather's going to be tomorrow. This is kind of what a weather forecast model looks like. And so, Mr. Tim, I want to share my screen right quick because I don't know if this question is going to come up, but it's a question that I have every year this time of year, and that is, am I going to have a white Christmas? So we talk about the computer forecast model. So Mr. Tim, if you could give them control of my screen, I want to show what's happening where all of us are. I'm in El Paso. Mr. Keith is up in Michigan, and you guys are in Virginia Beach. Now, this is in the morning when we wake up Christmas morning, okay? This is when we come and run and look under the Christmas tree to see all the presents that Santa has given us. And I always look outside to see if Santa gave me a little snow on Christmas. Well, if the computer forecast model is right, now it could change. If it's right, I think we're going to be real disappointed there in Virginia Beach because there's no snow there. There's hardly even any snow anywhere in Virginia, even up in the mountains to the west. Now, here in El Paso, I put a star where I'm located. Close, close, close. My goodness, it looks like there's going to be snow near me, but I think I'm going to wake up with big old tears in my eyes on Christmas morning. I hope Santa brings me some new toys to make up for the snow that's not going to be there. But Mr. Keith, I think he's going to be a happy camper on Christmas. Look at that Marquette way at the top with that star there. There's a number that says 10.2. It says he's going to have 10 inches of snow on the ground. Wow, I think we all need to ask Mr. Keith it'll be okay if we just come to his house and visit for winter time, or at least for Christmas, because he's going to get all the snow. But that's kind of how we forecast the weather. Now, will that be an exact forecast? We don't know yet, but we have tomorrow to change it. Right, Mr. Tim?
That's true. That's true. And it is amazing how the different weather varies across the country. And I don't think we mentioned this, but there are over 122 weather forecast offices around the country. And you saw they stretch from the southern border here along Mexico in El Paso all the way up to the Canadian border and the Great Lakes in Marquette. You've got offices in Seattle to Miami, from Gray, Maine to Los Angeles. They're all across the country. And like Mr. Jason said, because the important thing is that the local meteorologists know best what is happening in the local area. So, great question. You guys got any more questions for us? I know it's getting close to time to wrap up for you guys. Here it comes, the whiteboard. Do the astronomers take the weather satellite info, or do you? Great question. Great question. Because there are all kinds of satellites up there. Jason or Keith, can you get me a picture of a satellite so we can show them what it kind of looks like? Basically, there's lots of satellites. And NASA is kind of the space organization for the United States government. They have satellites up there. We're the weather organization. We have weather satellites up there. And they're different satellites. They do similar things, and we share the information with each other. and we actually work. Sometimes we actually launch satellites together. It's NASA and the Weather Service. It's actually called NOAA, is our parent organization, but we actually share the satellite. So here's what a satellite looks like. Let me throw this up on the screen here. Boop, boop. So it looks kind of weird, but basically it's got these sensors on the front of it that's always looking down at the Earth. Imagine if you put a camera up in space and it's always looking down. That's what the real simple way to think of these satellites is. They're always looking down at the Earth. There's a couple kinds of satellites. There's one that's way out in space at about 200 or 24,000 miles. And the way the Earth rotates, it actually follows the Earth exactly the way the Earth rotates. So it's always over the exact same spot. So we can take those cool images and glue them together to make that satellite loop, to make it kind of move along like a movie. We also have some satellites that are much lower down in space, and they're only a few hundred miles above the surface of the Earth, and they kind of go around the poles, and they keep going around. So they're going around while the Earth turns underneath them. So they'll come down and make a strip, and then the next time they come around, the Earth has moved, and they take another strip. And they can get much finer detail because they're so much lower down. The problem with polar orbiting is that they usually only cover one part of the Earth every, I don't know, couple of hours, whereas the geostationary satellites, they're always looking down at the Earth, always what you can see. And here are some satellite pictures. We have different kinds of satellite pictures as well. We have satellite pictures that are infrared, that kind of takes a picture of the temperature, the visible one. And actually, Jason, can you highlight there in northern Alabama and Georgia, there's some white in there? Guess what? That is not clouds. That is the snow that is left over from that snowstorm. Pretty impressive. Pretty impressive. So that's kind of cool, the way the satellite, the visible. This is I think that's water vapor. Yeah, that's water vapor. So that's a picture kind of showing us where the water, we were talking about how much water vapor is in the atmosphere and how that's important. The kind of the reds and the oranges is where it's very dry, and where you see the brighter colors, maybe like the whites and the blues and even the greens there up there in northern Montana and southern Canada, that's where it's very moist. There's lots of moisture in the atmosphere. This time of year, it's winter in the northern hemisphere, like we talked about. We don't have a whole lot of moisture in the atmosphere, so we try to squeeze out whatever we can, and a lot of times it falls as snow. But during the summer, that moisture in the atmosphere is very important because it shows us where those thunderstorms are. So there are lots of satellites up there. It was a great question. NASA has their satellites. We have our satellites. We share information. Sometimes we team up and we use the same satellites and things like that. So great question. Anyone else have a question there? You guys are doing great. Oh, it's time to go. Great job, everybody. Right. That's the wrap-up sign. Very good. Well, you guys did an awesome job there in Glenwood Elementary School. Let's give you all a round of applause. Good job, everybody. Good job. Good job. I'm glad we worked through our little technical problems there. You guys did a great job. I'm proud of you. Oh, we got a message there. We can email other questions. You betcha. I know you guys got to probably run. Feel free to email us those questions. We'd be more than happy to answer any of them because that's what we like to do. We like to talk to kids about the weather. We like to let people know the weather that's happening. It's a great job. I encourage you guys, if you're interested in science, to do that. So thanks, everyone, for joining us today. Thanks, Mr. Keith. Thanks, Mr. Jason, for joining us and giving us your wisdom about the weather. Awesome job, everybody. You guys have a great day there in Virginia Beach. Enjoy the cooler weather tomorrow because it's on the way. Have a great day, and we'll talk to you later. Bye-bye.